Magnet resonance imaging. The MRI, magnet resonance imaging, or nuclear magnetic resonance (NMR) tomography has emerged as a powerful imaging technique in the magnetic field because of its high resolution capability and potential for chemical specific imaging. Similar to what is the main comparison between NMR system and X-ray and CT? Similar to X-ray, the CT computed tomography, MRI uses magnetic field and radio frequency signal to obtain anatomical information about the human body as cross-sectional images in any desired direction. That is very important. Can easily discriminate between the healthy and diseased tissue. MRI images are essentially a map of the distribution density of hydrogen nuclei and parameters reflecting their motion in cellular water and lipids. The total avoidance of ionization radiation, its lack of known hazards, and the penetration of bone and air without attenuation make it particularly attractive non-invasive imaging technique. And the CT provides the details about the bone and tissue structure of an organ, but the NMR highlights the liquid-like areas in those organs and can also be used to detect flowing liquids like blood. A conventional X-ray scanner can produce an image only at right angles to the axis of the body, whereas the NMR scanner can provide any desired cross-section, which offers a distinct advantage and a big boon for the radiologist. The MRI system provides highly detailed images of tissue in the body. The system detects and processes the signal generated when hydrogen atoms which are abundant in tissue are placed in strong magnetic field and excited by a resonant magnetic excitation pulse. All materials contains nucleus that have a combination of protons and neutrons. It possesses a spin and the amount of spin gives rise to the magnetic moment. The magnetic moment has a magnitude and direction. In tissues, magnetic moments of nuclei making up the tissue are randomly aligned and net magnetization is zero. Now this is the MRI scanner. There is a patient, it will be a patient table here that the patient is placed, and there is a radio frequency coil, gradient coil, magnet and scanner. What are the basic NMR components? You will see then that the basic components are the first one, magnet. It will provide the strong, uniform, steady magnetic field. RF transmitter which delivers radio frequency magnetic field to the sample. Gradient system, it is the time varying magnetic field of controlled spatial non-uniformity. Detection system which yields the output signal, and imager system, it includes the computer which reconstructs the displays and images. This is the block diagram. You will see that it is the X gradient, Y gradient and Z gradient. There is a permanent magnet and receiver transmitter coil and receiver coil or power amplifier transmitter. It will be linked with the computer. We will detail study these components in the next slide. That the magnet. What are the basic NMR components? That the first one is magnet. In magnetic resonance tomography, the basic field must be extremely uniform in space and construct in time, as its purpose is to align the nuclear magnets parallel to each other in volume to be examined. Also, the SNR, it is the signal to noise ratio, increases approximately linearly with the magnetic field strength of basic field, therefore it must be as large as possible. Four factors characterize the performance of the magnets used in MR system: field strength, temporal stability, homogeneity, and bore size. The grass non-homogeneous result image distortion, while the bore diameter limits the size of the dimension of the specimen that can be imaged. Such a magnetic field can be produced by means of four different ways. It is a permanent magnet, electromagnet, resistive magnet, and superconducting magnets. You detailed studied these magnets one by one. There is a permanent magnet. In case of permanent magnet, the patient is placed in the gap between pair of permanently magnetized pole faces. Permanent magnet materials normally used in MRI scanners includes high carbon ion alloy such as alnico or neodymium ion. Although the permanent magnets have the advantage of producing a relatively small fringing field and do not require power supplies. They tend very heavily and produce a relatively low field in order of 0.3. That the electromagnets make use of soft magnetic material such as pole faces which become magnetized only when electric current is passed through the coil wound around them. Electromagnets obviously require external electrical power supply. The resistive magnets make use of the large current carrying coils of aluminum strips or copper tubes. In these magnets, the electrical power requirement increases proportionately to the square of field strength, which becomes prohibitively high as the field strength increases. Superconducting magnets. Most of the modern NMR machines utilize superconducting magnets. These magnets utilize the property of certain materials which lose their electrical resistance fully below a specific temperature. The basic NMR component, next component is RF transmitter. It contains RF transmitter, RF power amplifier and RF transmitting coil. In RF transmitter system, to activate the nuclei so that the immediate useful signal energy must be transmitted into the sample. The RF transmitter consists of an RF crystal oscillator at Larmor frequency. The RF voltage is gated with the pulse envelopes from the computer interface to generate RF pulses that excite the resonance. In RF power amplifier, these pulses are amplified at to levels varying from 100 watt to several kilowatt and are fed to transmitter coil. In RF transmitter coil, the coil generates RF field perpendicular to the direction of main magnetic field. Coils are tuned to the NMR frequency and they are isolated from the remaining system using RF shielding key. So this is the black diagram of your detection system, that the reference coil and the NMR signal, it will be phase sensitive with both the signal will be given to a force sensitive. There is a reference coil making the matching control and the signal is given to the preamplifier for amplification purpose. And the phase detective sensitive to phase sensitive detector, that the output is fed back to your LPF, low pass filter, that the low frequency component eliminated, and this eliminating signal is given to analog to digital converter and it will be given to a. The function of detection system is to detect the nuclear magnetization and generate an output signal for processing by the computer. In the imager system, the imaging sequencing in the system is provided by a computer. Functions such as gates and envelopes for the NMR pulses, blanking for the preamplifier, and RF power amplifier and voltage waveform for the gradient magnetic field are all under software control. The computer also performs various data processing tasks, including the Fourier transformation, image reconstruction, data filtering, image display, and storage. Therefore, the computer must have sufficient memory and speed to handle a large image arrays and data processing in addition to interfacing facilities. What are the advantages of NMR imaging system? It provides a substantial contrast between the soft tissue and nearly identical. No ionization radiation taking place and has minimum hazards for operators of the machines and for patients. And like CT and NMR imaging requires no moving parts. The system scans by superimposing electrically controlled magnetic field consequently. Scans in any predetermined orientation are possible. With the new techniques being developed, NMR permits imaging of entire three-dimensional volumes simultaneously instead of by slice employed in other imaging systems. In NMR, both biochemical and spatial information can be obtained without destroying the sample.